Hello, hello, and welcome to the core first semester final review. Let's do it. So we're going to begin with KC1. All right. Number 1, determine if each graph represents a function or not. Now the way we're going to do it is by using our vertical line test. So let's do it. I'm going to draw a line through this W shape. It only crosses once. That means it's a function. Let's draw it through this U shape. Crosses once, function. Let's cross it through this C shape. Crosses twice, not a function. Let's cross it through this V shape. Crosses once, it's a function. And then crossing through this circle, crosses twice, not a function. So how can we tell which graphs are not functions? They cross the vertical line test more than once. All right, so that's how we tell if graphs are functions or not. So let's do the same thing with tables. Now the way we look at tables is we just look at the x's. The x's cannot repeat. So in letter A, all of our x's are different. Perfect. Letter B, all of our x's are different. Perfect. Letter C, oh, we've got two x's that are the same. This is not a function. So how could we tell? The x's repeated. Okay. Number 5, let's identify the domain and the range of the tables below. Now our domain has to do with our x's. So we're going to write the set of our x's for our domain. I'm going to write them in numerical order: 1, 2, 3, 4, and 5. Our domain refers to our y's. They're not in numerical order here, but I am going to rewrite them in numerical order: 0, 4, 8, 10, and 12. Let's do the same thing for this table. Our x's are our domain. Let's write them: 1, 2, 3, 4, and 5. And of course we have y's: 1, 2, 8, 16, and 32. Our y's again are our range. Okay, speaking of range, let's identify it on the graph below. So this is asking us to find out from where to where do our y's go. Our y-axis is this one right here. I know it looks a little messy, but I'm highlighting it kind of with my pen. I want to see the lowest my graph goes and the highest my graph goes. All right. The lowest looks like -4. So y is between -4 and the tallest here. I know I drew over it, but that's an 8. So my range is between -4 and 8. Okay, let's continue. Number 7, let's complete the statement that describes our pattern. Each figure has blank than the one before it. Well, let's find out how many circles each figure has. This figure has 2. This one has 4. This one has 6. And that one has 8. So each figure has 2 more than the one before it. Number 8, arithmetic sequences repeat addition or subtraction, whereas geometric sequences repeat multiplication or division. So let's determine whether each of these sequences are arithmetic or geometric. And then we'll find the next term. All right, letter A. Oops, my bad. I'll scroll back down. All right, letter A. 0.1, 1, 10, 100. Now, those numbers are getting larger really fast. That means to me that it's geometric because it's multiplying. When numbers are getting really large really fast, that means it's multiplication. Multiplication makes things larger faster than addition can. So it's geometric. So the question is, what should I multiply 0.1 by to get 1? Or 1 to get 10, or 10 to get 100? Well, each time I have to multiply by 10. So 100 times 10 is 1,000. Letter B, 0.8, 1, 1.2, 1.4. Now, once again, these are getting larger, but in much smaller increments. So that tells me it's arithmetic. So addition also makes things larger, like multiplication can, but addition makes it larger in smaller increments. So the question is, what am I adding each time? Well, I'm adding 0.2 each time. So the next term would be 1.6. Letter C. Negative 172, negative 204, negative 235, negative 266. The numbers here are getting smaller, but they're getting small not that fast. So I'm going to say these are arithmetic, that I'm going to be subtracting. Now, what am I subtracting? Well, let's see here. To get from negative 172 to 204, I believe I'd have to subtract 32. Yeah. Right? 204 minus 172. Let's just double check. I don't know why. I'm, of course, doubting myself at the moment. Okay, that works. I think there's just a little typo here. This should be 236. That's why it confused me for a second, I believe. And that should be 2 actually. If with this typo, this could be not a function at all. This should be negative 268. Ooh, my bad there. Okay, so that's fine. Our pattern is by minus 32, and 268 minus 32 is negative 300. Oh, I'm glad I caught that. All right. Novi Elementary School has 2 disposable masks left on the playground. After Monday, there are 8 masks. After Tuesday, 14. After Wednesday, 20. If the pattern continues, how many masks will be on the playground on Sunday? Okay. Well, if there's 8 on Monday, 14 on Tuesday, 20 on Wednesday, what's the pattern? Well, it seems like I'm adding 6 each time. So let's continue the pattern for Thursday, Friday, Saturday, and Sunday. So 26, 32, 38, 44. Number 11. The Chicago Bulls franchise has agreed to donate $1,000 to Morton West to remodel the weight room. In addition, they donate $200 for every sports team that makes it to the playoffs at Morton West this year. Oh, wouldn't that be great, though? I already said that. The sequence shown represents the possible amounts the Chicago Bulls franchise will be donating. Write a function to model this situation. Oh, oops. Come back here. There you are. All right, so let's see. We start off with AN. A1 is our first term. And D is our pattern. And then N minus 1 goes next to it. But let's find out what our pattern is. To get from 1,000 to 1,200 to 1,400 to 1,600, etc., we add up 200 each time. And you could have gotten that from here, that they're going to donate 200 each time. And that's where we got our 1,000 from. Okay, onwards we go. Use the following graph to find the rate of change for this linear function. Okay, well, here we need to find our rise over our run. I'm going to use these 2 points. Let's see how it goes. And I'm always going from the left to the right, by the way. always do it that way. It keeps it consistent. It seems like I'm going down 2. And how many am I going to the right? 1 to the right. So negative 2 over 1 is our slope. Find the average rate of change in these two tables. Okay, well, we're kind of doing the same thing, but we're going to look at it more algebraically. We're going to be using the following formula. y2 minus y1 over x2 minus x1. All right. You know how I like color coding. Let's do it. Oops. I totally selected the... Did I delete my highlighter again? I so did. All right. This is my first x, so that's going to be x1. This is my second x. That's going to be x2. This is my first y. That's going to be y1. This is my second y. That's going to be y2. Let's plug everything in. All right, so I have negative 4 minus negative 14 over negative 2 minus negative 4. And let's color code this up. Oh no, I did it again. I don't know what I keep clicking, but I click something that deletes my highlighter somehow. All right, in my calculator, I entered negative 4 minus negative 14, and I got 10. Negative 2 minus negative 4, I got 2. And you can, of course, simplify it to 5. Let's do the same thing for letter B. Using the same formula. All right, let's do it. Let's color code it up. x1, x2, y1, y2. Let's plug in the numbers. 30 minus 45 over negative 6 minus negative 11. And you know I've got to color code it. Okay. All right, in my calculator, I put 30 minus 45, and I got negative 15. Negative 6 minus negative 11, I got positive 5. And we can simplify that to negative 3. Wonderful. Let's continue. Number 14. Let's determine whether or not each of these charts represents a linear function. Now, what this means is we want to make sure that the pattern is the same in the x's and the y's. So let's see here. In the x's, I have plus 1, plus 1, plus 1. Perfect. All right, so the pattern for the x's is consistent. Let's do our y's. Plus 3. Plus 5. I can stop there. This is not a function. This is not a linear function. It's not a consistent rate of change. So let's continue to letter B. Our x's look like each of them is doing plus 1 again. Beautiful. Let's check out our y's. This is plus 3, plus 6. We're done. This is not linear. Letter C. Each of the x's looks like it's going plus 1. Wonderful. Minus 4, minus 4, minus 4. All right. One of them is a function. Well, actually, not necessarily. This letter C is just a linear function. The other two could be nonlinear functions. We don't know that yet. But we definitely know that letter C is a linear function. All right, number 15. Let's rewrite each of these expressions using the distributive property. So distributive property is a fancy way of saying multiply what's next to the parentheses inside of the parentheses. So I'm going to multiply 5 times x, 5x, 5 times 4, 20. One more time. 2 times x is 2x. 2 times negative 4 is negative 8. And let's do it one more time for letter C. Negative 3 times 2x is negative 6x. Negative 3 times negative 7 is positive 21. Don't forget, negative times a negative is a positive. Ooh, 16. We're going to solve each equation and determine the solution. Okay. Now, number 16a, I notice parentheses, so I know my first step here is to distribute. So let's do it. 6 times x is 6x. 6 times negative 5 is negative 30. The negative 16 and the equals 2 just come down. There's nothing that we could do with them yet. On the left-hand side, I see 2 like terms that can combine. On the left side of the equal sign, do you see what we can combine? We can combine this negative 30 and negative 16. So negative 30 minus 16 is negative, whoops, I almost wrote 36. It's negative 46. And it equals 2. Now, we're getting closer to getting x by itself. Let's continue by undoing the minus 46 by adding 46 to both sides of the equal sign. So we've got 6x equals 48. And let's finish up by dividing both sides by 6. X equals positive 8. Success. Let's move on to letter B. Once again, I see some parentheses, which is telling me it's time to distribute. So let's do some multiplying. Negative 8 times x is negative 8x. Negative 8 times negative 3 is positive 24. And bring down the minus 7, the equals, and the 73. On the left side, once again, there are some like terms that I can combine. The 24 and the minus 7. So this becomes negative 8x plus 17 equals 73. My next step is going to be to move that 17 to the other side. So I'm going to undo it by subtracting. So I'm left with negative 8x equals 56. And of course, let's finish up by dividing both sides by negative 8. X equals negative 7. All right, onwards to letter C. Oh, wonderful. This is so much smaller. There's going to be less to do. So I don't have to distribute anything. So I'm going to start off by adding 3 to both sides. So I'm left with negative 7 equals negative 35. And of course, I get to finish this up by dividing both sides by negative 7. X equals positive 5. Oh, that was quick. Let's take a look at letter D. Also looks like a short one. There's no parentheses, so nothing to distribute. So the first thing I'm going to do is subtract 5 from both sides. So I'm left with negative 4x equals negative 44. And of course, let's finish. Oh, I meant to do that in a different color. Let's finish by dividing both sides by negative 4. I totally erased too much. So we have x equals positive 11. All right, not too bad, not too bad. Let's continue on. Not to the top of the document, silly. Let's go back down. There we go. Letter E. All right, so nothing to distribute in letter... Oh, did I zoom in too much again? It's being picky, isn't it? All right. No way. Come on, buddy. All right. Won't zoom in any more than this. I got it. I learned my lesson. Okay. So letter E. I don't see any parentheses, so I'm not going to be distributing anything, but I do see some like terms on the left side. Do you see those like terms? It's that 10x and the plus 2x. So 10x's plus 2x's gives us 12x. And of course, the minus 14 and the equals 22 come along. Okay. Now, let's work on getting x by itself. So the next step that I'm going to be taking is adding 14 to both sides. So I'm left with 12x equals 36. And of course we can finish by dividing both sides by 12. I think I'm going a little too fast for my tablet. Sorry. Sorry, tablet. I'll go a little slower. X equals 3. Oh. I'm going to have to be a little gentler with this tablet. Come, buddy. I guess it shouldn't be as picky if that 12 isn't orange. Ah, beautiful. All right, let's do letter F. Letter F, I don't see any distributing or anything that I can combine on the same side, so I'm going to begin by subtracting 2x from both sides so that I have my x's on the same side. 7x minus 2x leaves us with 5x. The minus 25 I bring down, and the 175 is left over on the right side. Next, let's add 25 to both sides. And we have 5x. Oh. I went too fast for my tablet again. I switched the colors so quickly. Alright, we got 5x equaling 200. And of course we're going to finish this up by dividing both sides by 5. X equals 40. Alright, onwards we go. Ethan saved $77. He already spent $9. He plans to spend $4 on Starbucks coffee each week to treat his teachers. That's so nice of him. Choose the inequality that represents the number of coffees C he could buy. Well, he can spend no more than $77. So $77 should be on the bigger end of the inequality sign, which luckily all 4 of our options have. Okay, perfect. Now the total he can spend is 4 per coffee and the 9 that he's already spent. So total and are both words that represent addition. So letter B is going to be our answer because it's $4 per cup of coffee and the $9 he already spent. The total of that should be less than the $77 that he has saved. Number 18. Let's graph these inequalities. Well, in order to graph them, we need to solve them first. In letter A, I'm going to solve it by dividing both sides by -8. Now, what's important here is to remember that when you divide by a negative number, the symbol, the inequality symbol, flips. All right, let's graph this. X is less than negative 3.75, so that is somewhere around here. Putting an open circle because doesn't have an or equal to, and x is less than, less is left. All right, let's do the same thing in letter B. We're going to divide both sides by 6. Now this time we divided by a positive number, so our symbol will not change. We will still have the symbol facing the same direction. So I should have x is greater than or equal to negative 1.8. So negative 1.8 is right here. It's a filled in circle because it has an or equal to, and greater than is to the right. Okay. Letter C, okay. couple more steps than usual. I'll start by adding 3 to both sides of the inequality symbol. So we have negative 2. It's just not loading the black. Let's try that again. We are left with beautiful negative 2x. We didn't divide or multiply by a negative, so our symbol stays the same. Negative 8 plus 3 is negative 5. Now I'm going to divide both sides by negative 2. Now our symbol flips. So instead of x is less than or equal to, we're going to have x is greater than or equal to positive 2.5. Because it's greater than or equal to, we get a solid dot on 2.5. Greater than has a shading to the right. All right, onwards we go. Number 19, let's determine how many solutions each system has. The way I did all 4 of these problems is I went into my calculator. I clicked menu, then I clicked the 3, the 2, and then enter. I made sure that while I was entering my equations, I was clicking the X and Y on the bottom of my calculator that are white, and using the little equal sign that's underneath the yellow control button. Number 19 gave me a funky answer with letters like C1 or C2. Well, that means for us is that we have infinite solutions. Why aren't we writing? Oh, I selected my eraser. Go me. Infinite. And of course, you can write the infinity symbol. Letter B, when I entered this in, it literally said no solution. Beautiful. Our calculator knows how to give us that. Letter C, when I typed that one in, I got an actual answer, which means we have one solution. Letter D, I typed this in and it gave me no solution. Number 20, let's solve by substitution. Okay, what we're going to do is we're going to take this y equals and we're going to plop it into that second equation. All right, so instead of 6x plus y equals 18, oh, I'm trying to highlight. There we go. We are going to have, see, that's me going too fast again. Sorry, y'all. Let's erase that. Smudge. And let my pen slowly load. All right, beautiful. So we have 6x plus 5x minus 4 equals 18. So instead of the y, we have 5x minus 4. As you can see that once again I went so fast that I drew a line instead of my highlighter. I'm trying to erase this little smudge. Ah, there we go. That worked. Okay, now then, now that we took the 5x minus 4 and we replaced it instead of y, we can begin solving this like a regular equation. So what I notice is that we have a 6x and a 5x. I can add them together to get 11x. And then minus 4 comes down, so does the equals 18. Next, I'm going to add 4 to both sides. So we've got 11x equals 22. And I finish this up by dividing both sides by 11. All right, 22 divided by 11 gives us that x equals 2. Wonderful. We found x. Now that we have x, we can easily find y, and this is how we're going to do it. we're going to use this top equation. So x is 2, which means I can write, instead of y equals 5x minus 4, I'm going to plug that 2 in for x. So 5 times 2 is 10. Y equals 6. So our final answer for this problem would be 2, 6, because remember we go x, y in that order. All right, letter B. Y equals negative 2x, minus 8. And then we have that second equation. There it is. Once again, we're going to be substituting in this y equals equation into that second one. All right, so this is what it's going to be. I'm going to undo that. There we go. All right, so we're going to have 7x plus y equals 7. And instead of the y, we're going to have minus 2x minus 8. And of course, let's highlight that. Okay. Now that we are dealing with just x's, we can solve it like a regular equation. Oops. Let's undo that. Oh, me and my slow loading tablet. I think I'm just going too fast. Too fast. Okay, so what I'm going to do is I'm going to combine the 7x and the minus 2x. 7x's minus 2x's gives us 5x's. And of course I bring down the minus 8 and the 7. Let's continue by adding 8 to both sides to undo the minus 8. We're left with 5x equals 15. How wonderful, because all we have to do now is divide both sides by 5. And we are left with x equals positive 3. Wonderful. Now that we have x, we can take it and plug it in to that top equation and find y. So instead of negative 2x minus 8, we can write negative 2 times 3 minus 8. Negative 2 times 3 is negative 6. And negative 6 minus 8 is negative 14. So our final answer is 3, negative 14, because we always write x, y. All right, let's continue. Oops. Solve each of the system through linear combination. So this is where we're going to have to do some multiplying. I'm going to see how much I can zoom in before it gets angry at me. Okay, I'm not going to risk it. No! It got angry. Okay, this is as far as I'll go. So what we're going to do here is we're going to look at the x's and the y's and see if we see any opposites. Now, what I notice is that I have almost opposites. I have a positive y and a negative y. I'm going to force them to become opposites. I'm going to do this by multiplying the top equation by 2, because that's the number on the bottom next to the y, and the bottom equation I'm going to multiply by 5. So let's see what happens. So if we do this right, our y's will be able to cancel out. Just waiting for my pen to turn back to black. There we go. All right. 2 times 2x gives us 4x. 2 times 5y is 10y. And 2 times negative 7 is negative 14. 5 times 6 is 30x. 5 times negative 2y is negative 10y. And 5 times 30 is 150. And I gotta say, we succeeded. Our y's are officially opposites. Positive 10, negative 10. Because they are officially opposites, this means that we can add them going up and down. Now, I'd like to do this. I wanted to change my pen color here, but it's not quite loading. So I'm just going to use this pencil and write a plus sign. Beautiful. There we go. Okay, so our y's cancel. Beautiful. 4x plus 30x is 34x. Negative 14 plus 150 is 136. And we have just one last step left here, and that's to divide both sides by 34. So x equals positive 4. Now, it doesn't matter which equation you plug this into, so I feel like plugging it into the top. So instead of 2x plus 5y equals negative 7, I'm going to write 2 times 4, because that's what x is, plus 5y equals negative 7. I'm just going to solve this like regular. 2 times 4 is 8. I'm going to go ahead and subtract 8 from both sides. So I'm left with 5y equals negative 15. And of course, we're going to finish this up by dividing both sides by 5. Y equals negative 3. So our final answer here is 4, negative 3, because we read our answers as x, y. All right, so that's 21A. Let's do the same thing for B. So once again, I'm looking for opposites, and I notice almost opposites again. I notice them in the y's. Just waiting for my pen to turn into my highlighter so I don't draw over. Beautiful. All right, so let's try to get rid of our y's again. So the way we're going to do this is by multiplying the whole top equation by a 3, and the whole bottom equation we're going to multiply by 6, because we want them to match. We want them to be perfect opposites. Okay. Let's see. I'm waiting for my pen to turn back to black. La 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 la. Hope studying for finals is not too bad for you. Okay, perfect. Okay, so let's see. 3 times 5x is 15x. 3 times 6y is 18y. And 3 times 35 is 105. Let's do the same thing on the bottom. 6 times 10x is 60x. 6 times negative 3y is negative 18y. And 6 times negative 5 is negative 30. We have succeeded in making our y's opposites. I'll highlight them as soon as I can. There they are. Let's add them going up and down, because now we know that they will definitely cancel. Well, I'm trying to wait patiently. There we go. Let's add. All right, our y's cancel. Fantastic. 15x's plus 60x is 75x. 105 plus negative 30 is 75. How wonderful. Let's divide both sides by 75. X equals 1. Now that we have x, we can find y, and it doesn't matter which equation we use. I feel like using the top one again. All right, instead of 5x plus 6y, I'm going to have 5 times 1 plus 6y. 5 times 1, of course, is 5. I'm going to subtract 5 from both sides to begin with. So 6y equals 30. And of course, I'm going to finish this up by dividing both sides by 6. Y equals 5. So our official answer here is 1, 5, because of course we write x, y. All right, so not too bad. Don't forget, you can always use your calculators to help you solve these. Wow, that went to the bottom this time. Interesting. All right, well, we'll move on to number 22 in just a moment, once I guess the document decides to load. No. Okay, I thought it erased everything I did. I was about to be quite sad. Oh, thank goodness. Oh my. My heart skipped a beat right there. All right. What we're going to do, number 22, is write an inequality that represents each graph. That means we're going to have a y. We're going to have some symbol. We're going to have mx plus b. All right, so let's get started with y. Y is y. Now, the way we determine the symbol is by determining whether or not we're shaded up or down in our line. The way I do this is I put my pen or pencil anywhere on my line, and then I'm going to pull either straight up or straight down. And I want to pull towards the shaded area. If I pull straight up, I go towards the shaded area, which means this is a greater than symbol. It does not have a line underneath because it is a dashed or dotted line. Next, we need to find the slope. I want to see if I can find a different color pencil, if it will allow me to pick one. Ooh. No? Not today? Not today, I guess. What if I add a pen? No. Ooh, let's just use this colorful galaxy one. Okay. So for our slope, we gotta pick 2 perfect points. Let's use this one and this one. And we're going to determine how much up or down and then to the right we go. Well, it looks like we're going up 2 to the right 1. So our slope is positive 2 over 1. Ooh, I like this. This is actually a cooler pencil than I would have imagined. I'm trying to write my X in regular black pencil, but it doesn't seem to want to now. Well, as I try to make this work, I just want to let you know X is X. So that doesn't change. X and Y represent the X's and the Y's. Come on, let me erase this. Friends? No? How sad. Aha! I did it. Okay. Success. Alright, so X is X. Now all I have to do is wait for this to turn into a pen again. Pen? Maybe? Maybe pen? Well, let's give it a moment. The next thing we need to look for while it's loading for me is B, and B is our y-intercept. So let's find that y-intercept. The y-intercept is where a graph crosses the y-axis, and it looks like it's right here at positive 1, so I write plus 1. And that's it. Let's do the same thing for letter B, and hopefully we have a little less of a hard time with this. All right, so once again, we have our... Just going to cross this off because I don't want to make it load. We have Y. We're going to have some sort of symbol, an MX, and a B. So we start off with Y, and now let's determine our symbol. The way we determine our symbol is we put our pen or pencil on our line, and then we're either going to pull straight up or straight down towards the shaded area. Now notice if I pull down, there's no shading. If I pull up, now there's shading. So this is going to be greater than again. And because it's a solid line, my symbol gets a solid line. Next, let's take a look at the slope. We need to use 2 perfect points for the slope. I'm going to use this one and this one. All right. Going left to right, let's count our slope. It looks like I'm going down. I'm going down 1, 2, 3, and then to the right 1. So our slope is -3/1. And I actually have already crossed or put a dot on the y-intercept. Our y-intercept is +4. That's where we crossed the y-axis. All right, beautiful. Onwards we go to our last problem. Our last problem states circle all of the points that are a solution to the graphed system of equations. The way we do this is we graph each point. Let's get started. Letter A is at -4, 0. This is not a part of the solution because it's not on the solid line that's a part of the shaded area or the shaded area. Right, letter B is -4, 0. Oh man, that is so close, but no, it's on the dotted line. B doesn't work. Okay, let's graph letter C. -2, -2, success. This lands on the solid line that's attached to the shaded area. Letter D, -4, -6, right in the middle of the shaded area. Beautiful. Letter E is 4, 1. Ooh, it's on the solid line, but it's not attached to that shaded area, so no. And then finally, letter F, not even close. And that's about it. Sorry about my weird technical issues that I was having with my pen. I wasn't able to color code the best to the best of my abilities, but you know, it is what it is. If you have any questions, please make sure to ask me or your teachers. Oh no, it looks like my work's gone again, but I know from last time it didn't actually disappear. I think it's just loading. Anyways, good luck on your finals, and have a good rest of whatever day it is for you. Bye!